Okay, welcome back to class. The first part of the module, like I said in the overview, I'm breaking these up in small kind of increments because I don't want you to have to sit there for a bunch of time and then at the end of it go, I have no idea what I just looked at. So, and you can go back and reference these pretty easily. All of these are going to be YouTube based. So anyway, the first part of the course, we're going to talk about some fundamental things of the atmosphere. This, particularly, why is it important? We need this fundamental kind of building blocks to the atmosphere and the oceans and things like that in order to understand, and the cryosphere too. That's all the ice-based parts of the Earth. We need to understand those fundamentally in order to understand the problem of climate change. So why is the atmosphere important? Well, we need to be able we need the gases from the atmosphere to live. Plants do as well. Um, the atmosphere is made up of the perfect type of chemistry for animals like us to live. Another thing is the atmosphere actually shields us from dangerous solar radiation, specifically ultraviolet radiation. We know because we get sunburns and things like that our skin is um, pretty susceptible to harmful types of things from ultraviolet rays from the sun. So parts of the atmosphere, specifically in the stratosphere, which is just above us, we're in the troposphere, and we'll learn that throughout this module. Um, in the stratosphere, there's a layer of ozone, which is a greenhouse gas, and we'll also talk about greenhouse gases this module. It does a really good job of absorbing the sun's ultraviolet radiation. Now, it doesn't absorb everything, but it'll let some through because it's not a continuous layer. But it still does a really good job of absorbing those wavelengths of radiation. Also, the atmosphere shields us from space debris. The friction from the atmosphere burns things up like meteors. It keeps temperature at the surface ideal, which we'll talk about the whole greenhouse effect and how it keeps our temperature warmer than it would without it. We can transmit sound. We get our weather from the atmosphere. So we'll also talk about the difference between weather and climate. There's some subtleties, but you got to understand that. And then lastly, the energy from the sun, which is solar radiation, causes the atmosphere to circulate, which creates our weather. The reason that it does, in a nutshell, is the way that land and water is over the Earth, is not uniform, and they all heat differently. Because they heat differently, the oceans and the atmosphere circulate. That's very simplified, but it's something that just is in our atmosphere. Okay, quick overview of the Earth's atmosphere. It's very thin, actually. How deep is it? Hundreds of kilometers, actually, but 99% of the atmosphere lies within 30 kilometers. So, in a nutshell, if the Earth were, say, some type of ball, beach ball or something like that, the atmosphere would be as thin as a piece of paper that's wrapped around that ball. So very, very thin, and most of it, because of gravity, lies within 19 miles of the surface. Composition of the atmosphere. So we have a number of gases and greenhouse gases that make up the chemistry of the atmosphere. Nitrogen is about 78%, oxygen 21%, and then water vapor here is 0 to 4%. So depending on where you are, water vapor is much higher in the tropics than it is in the Arctic, for example. Another thing that you'll get out of this class that I think might interest some of you is that water vapor actually is the most plentiful greenhouse gas in our atmosphere. A lot of people think it's carbon dioxide. Carbon dioxide is probably the most popular greenhouse gas. It gets a lot of the press, but water vapor is actually the most plentiful, actually by far. It's much more than carbon dioxide. Here, I won't make you responsible for these permanent gases. I wouldn't worry too much about them. Over here, we have variable gases. These are greenhouse gases. So we've got water vapor, carbon dioxide, methane, nitrous oxide, ozone. Don't worry too much about the percentages and things like that, except for water vapor and carbon dioxide, I think are important. Then we also have impurities, pollution, dust, soot, volcanic ash, things like that. And then we have these things called chlorofluorocarbons. So these are molecules that are man-made that actually float up. They're super light. They float up to the stratosphere and attach to ozone and destroy the ozone. So we've had something called the ozone hole that I'm sure everybody's heard about. We won't talk just heavily about it in this class because we're talking climate change, but it's something that exists in our atmosphere, although less so lately because of the problems that they cause. This slide talks about carbon dioxide. It's a small percentage, but very effective of a greenhouse gas, just like water vapor. Small amounts of CO2, plus or minus, actually have large effects on what happens to the surface of our planet as far as temperature goes. There's different sources and sinks. So sources, volcanic eruptions, we breathe out carbon dioxide, deforestation, burning of fossil fuels, and then sinks, plants take in CO2, oceans, and then biological things in the ocean, such as phytoplankton. So it'd be a good idea to know, be able to rattle some of these off. Other gases, ozone is another good one. We talked about the ozone hole already. It's very, very efficient at absorbing UV radiation. So that's a good thing for us. It keeps those less of those rays hitting us, which are harmful and actually have been known to cause skin cancers and things like that. And then you've got aerosols and pollutants. The interesting thing about aerosols is they actually kind of do the opposite of greenhouse gases. They don't absorb the radiation, they actually reflect it. So if you have a volcanic eruption like this one, a lot of radiation gets reflected back out to space, and you end up with a short-term net cooling effect. But what we saw from the previous slide, that volcanoes are actually sources of CO2, the long-term effects of volcanic eruptions are actually not very good, and very major increases in carbon dioxide. And that's going to do it for this section. Next section we'll talk about layers of the atmosphere.